warahmatullahi wabarakatuh. So for today, we are going to present about subnetting IPv4 addressing by using packet tracer. So before we start, if you have any comment or question, you can write it in the comment section below and don't forget to subscribe this channel. So before we proceed, I'm going to introduce you to my group members. The first one is Muhammad IQBAL bin Rahmat. The second one is me myself, Muhammad Zaqwan bin ZULKEFLI. The next one we have ALIF Zaqwan bin Muhammad Ali HANAFIAH, and the last but not least we have Muhammad PUTRA SYAZANI bin Muhammad ZAINI. So we will proceed with our topic, what is IP address? An IP address is a unique address that identifies a device on the internet or local network. IP stands for the Internet Protocol, which is the set of rules governing the format of data sent via the internet or local network. IP essence, IP address are the identifiers that allow information to be sent between devices on network. They contain location information and makes device accessible for communication. The internet needs a way to differentiate between different computer routers and websites. IP address provide a way of doing so and form an essential part of how the internet works. An IP address is a string of numbers separated by numbers period. An IP address are expressed as a set of 4 numbers. Each number's inside can range from 0 to 255. If you want to understand why a particular device is not connecting in the way you would expect, or you want to troubleshoot why your network may not be working, it helps understand how the IP address works. Internet protocol works the same way as any other language, by communicating using set guidelines to pass information. All devices find, send, and exchange information with other connected devices using this protocol. By speaking the same language, any computer in any location can talk to one another. And for your information, IP address is a connectionless protocol, which means that each unit of data is individually addressed and routed from the source device to the target device, and the target does not send an acknowledgement back to the source. That's where protocols such as Transmission Control Protocol (TCP) come in. TCP is used in conjunction with IP in order to maintain a connection between the sender and the target to ensure the packet order. So next we proceed to what is IPv4. For your information, Internet Protocol version IPv4 is the 4th version of the Internet Protocol. It is the one of the core protocols of standard-based internet networking methods in Internet and other packet switches network. IPv4 is still used to route most Internet traffic until today, despite the ongoing deployment of a successor protocol IPv6. IPv4 uses 30-bit addresses, which limits the address space. IPv4 addresses may be represented in any notation expressing a 32-bit integer value. They are most often written in dot decimal notation, which consists of 4 octets of the address, expressed individually in decimal numbers and separated by periods. So we are going to proceed with the next slide, which is the key features of IPv4. There are a few key features of IPv4. The first one is it is a connectionless protocol, and the next one, IPv4 is already supported protocol by millions of devices. And the next one is it requires less memory and ease of remembering addresses. And the last but not least is allow creating a simple virtual communication layer over these diversified devices. So for the next slide is what is subnet mask. A subnet mask is a 32-bit number created by setting host bit to all zeros and setting network bits to all ones. In this way, the subnet mask separates the IP address into the network and host addresses. Subnetting is a technique for logically partitioning a single physical network into multiple smaller subnetworks or subnets. Subnetting enables an organization to conceal network complexity and reduce network traffic by adding subnets without a new network number. When a single network number must be used across many segments of a local area network or LAN, subnetting is essential. So here we will tell a few benefits of subnetting. The first one is reducing broadcast volume and thus network traffic. The second one is enabling work from home, and the last one is allowing organization to surpass LAN constraints such as maximum number of. So the next is tasks to be undertaken and the solution. And the next slides we will be subnetting the assigned work and also addressing table, and we will make a device configuration, which is the demonstration, and last but not least is a troubleshooting the problem. So without further ado, I would like to pass to the next presenter.
Thanks to the previous presenter. And now, based on the given assignment, this is the question that needs to be solved. Step 1. Create a subnetting scheme that meets the required number of subnet and required number of host addresses. You must create multiple subnets out of the 192.168.0.0/24 network address space to meet the following requirement. A. The first subnet is the LAN A network. You need a minimum of 50 host IP addresses. B. The second subnet is the LAN B network. You need a minimum of 40 host IP addresses. C. You also need at least 2 additional unused subnets for future network expansion. Note: variable length subnets marks will not be used. All the device subnet marks should be the same length. On to the question. Question 1A. How many host addresses are needed in the largest required subnet? As you can see here, 50 hosts. 1D. What is the minimum number of subnet required? 4 subnets. As you can see here, the first subnet is LAN A and the second subnet is LAN B. And on C, you also need at least 2 additional, and that's 4 subnets. 1C, the network that you are tasked to subnet is 192.168.0.0/24. What is the 24 subnet marks in binary? As you guys can see here, I have the answer. I highlighted it for you to see. Alright, on to the next question. 1D. In the network marks, what do the ones represent? It's for the networks. In the 1E, in the network marks, what do the zeros represent? It's for the host and network. Alright. On to the next question. 1F. Given each of the possible subnet marks depicted in the following binary format, how many subnets and how many hosts are created in each example? Alright. For the first question, 25 subnets. Dotted the decimal subnet marks equivalent. The answer is 255.125.128. The total 8 of number 1 is equivalent to 255 per decimal. And as you can see here at the back, there is a single number 1 and a total of 7 for number 0, and that is for the 1 to 8. And for it to be 1 to 8, you have to count the 0 and make it for 2 to the power of 7, because the 0 has a total of 7 in it. The number of subnet and the number of hosts. Subnet is 2 and the host is 126. The number of subnet and the number of hosts. For the subnet, it is, if you remember back, that is subnet is represent as ones in binary, and host represent zeros is represent host in binaries. I'm sorry. And for it to be 2, there is a single one, and 1 to 2 to the power of 1, and the host, there is total of 7 for number 0, and that is 2 to the power of 7, and that's the answer you can get. Host 1 to 6. For the question 2 to 6 is the same, using the same method as the first question that I do. Alright. on to the next question 1A. Considering your answer above, which subnet must meet the required number of minimum host addresses? And that is 25 and 26. 1H. Considering your answer above, which subnet must meet the minimum number of subnet required? And it is 26, 27, 28, 29 and 30. And for the last question, considering your answer above, which subnet must meet both the required minimum number of hosts and the minimum number of subnet required? And the answer is 26, because 26, the number of subnet is 4 and the number of hosts is 62. Alright, and that's it for me. I will now pass it to the next presenter.
Thanks to the previous presenter, we can continue to fill in the rest of the addressing table based on the question. Thanks for them, because we can get many valuable information that should be usable to complete this table. So the first question is, assign the first subnet to LAN A. 1. Use the first host address for the customer router interface connected to LAN A switch. So this is an addressing table. This is gigabit 0/0 IP address. The IP address for gigabit 0/0 we can take from first usable IP address. So we copy from here and paste. And paste here. And back. So the next one is subnet mask. Subnet mask will be the same because we use 26 prefix, and the subnet mask is suitable for this system. So at this table we have a subnet mask, and we copy from this and paste here. For the second question, use the second host address for the LAN A switch. Make sure to assign a default gateway address for the switch. So LAN A, LAN 1 IP address we can take from the same, we can take here, but we must +1. Oh, sorry. We must +1, 0.1 become 0.2. So subnet mask will be the same. And the default gateway we will take from here. So the next question is, use the last host address for PCA. Make sure to assign a default gateway address for the PC. So PCA NIC IP address. So this we can take from this plus usable IP address for P, and we paste here. So subnet mask will be the same. So for the default gateway, we take from here. It is the same as the LAN A. So the A question is we have done. So let's move to B question. B. Assign the second subnet to LAN B. First one, use the first host address for customer router interface connected to LAN E switch. So customer router gigabit 0/1, we will take IP address from here. And the subnet mask will be the same. So the second question, use the second host address for the LAN B switch. Make sure assign a default gateway address for the switch. So LAN B switch VLAN 1. So we can take the IP address from here. But at the same for the LAN B, we must plus 1. So signify will be 66. For the subnet mask will be the same. And the default gateway we will take from this. Alright, so the next question is, use the last source address for PCB. Make sure to assign a default gateway address for the PCB and IC. We will take the IP address from, wait a minute. Oh, sorry. For the PC, yeah, okay. PCB we will take from here. And we will paste here. So the subnet mask will be the same. And the default gateway we will take from here. So that's all for me. I will pass to the next presenter to finish the mission. Thank you.
So thanks to our previous presenter, there is very many of valuable information that has been gathered to successfully build this system for this connection. So for my part is the part 2 for configure the device. First thing first, you need to set up the device according to the topology in this diagram in your Cisco. So I already did that part and copy the same way, the exact same way. But the only thing that need to be done is to configure the device itself. So first thing first, we need to configure the customer router. So to configure it, you have to click on it and then go to the CLI or command line interface and then press enter. Okay, to start the configuration, you need to enable it. So type in enable, that is configure terminal. After you have configured the terminal, you need to set the host name for this router, which is customer router. So host name customer router, and then press enter. After that, based on the question that are given, we need to set the enable secret password on customer router to class 123. So how do you do that? It's simple actually. You just type in enable secret enable secret, plus make sure the spelling is correct according to the question that are given. So class 1 to 3. And then the next step is line command 0. Oh, sorry, there should be no space there. I will retype it again. So actually the error here is line con 0. Okay, that's it. My bad. So for the password is password according to the question Cisco 123. Cisco 123 and then enter. So next is the login interface, gigabit Ethernet. You need to set up the interface for the gigabit Ethernet 00. So we need to put it down the IP address. Oh, I'm sorry. I should open the addressing table. So the addressing table is here, which is here. IP address it here, and then paste. And then after that is the subnet mask, which is here, and then paste and enter. Okay, already done for the gigabit Ethernet 00. Now we need to enable the interface by using the no shutdown command. Okay, it's already been enabled. Next, we do the gigabit Ethernet 01. So the same exact procedure. Interface gigabit Ethernet 0/1. Then we need to type in the address code, which is here. And then the subnet mask, which is the same. And then click it and once again enable it by using the no shutdown command. Okay. And then the last one, we need to do the serial 010. We need to enable it, the interface. Serial capital letter 010. Sorry, there is no space. Okay, that should be good. Okay, we need to type in the IP address. Then IP address is, and then the subnet mask. Then enter, and once again no shutdown to enable the interface. Then based on the question, we need to save the running configuration to the startup configuration file. So how do you do that? First, you need to click on Ctrl+Z. Then after that is type in copy running config. Oh, sorry, there is an error. There should be no space, only dash. and then done. Okay, that's it. We already configure the customer router. So let's move on to the next step, which is configure the two customer LAN switch. So for the LAN switch, again, go to the CLI, command LAN interface, and then press enter. So for the LAN A, first thing first, we need to enable it, and then configure terminal. After we have configured the terminal, we need to put in the interface. So in this switch, we use VLAN, which is here. So interface VLAN 1, type in the IP address, and then the subnet mask. Okay, now shut down to enable it again, and then give it the IP default gateway, space only dash, which is already stated here. Okay, that should be fine, and then end. Okay, so that's it for the LAN A. We are done for LAN A, and then we repeat the same step, the same step for the LAN B. Okay, after you have configured both of the LAN A and LAN B, we need to do the step 3, which is configure the PC interface. So to configure the PC, you click on it, and then go to the desktop, and then the IP configuration. After that, we need to use the addressing table to copy down all the important details, such as the IP address for PCA, which is here, and then subnet mask, and then the default gateway, and that's it. We are done. Then goes to the PCB. I will show you just one more time, just in case. So put it in static for PCB, IP address, put it here, subnet mask, same, and then lastly default gateway, and that's it. We are done. So how do we know that our connection has been established? We need to troubleshoot it. So how do we troubleshoot it? In the part 3, they ask you to use the ping command to get if there is any reply. So let's start from PCA. We go to the desktop, and then type in ping, and then get the PCA. Get the PCA IP address, which is here, ping 192.168.0.65. So as you can see here, there is actually an reply. So the connection is okay. Let's try again for the PCB if there is any reply. So same command, ping, and then put in the PCB IP address 192.168.0.126. Okay, and that is for the question B. You get a reply. After that, for the question C is if you can communicate PCA to with PCB. So how do you do that? Ping from PCA, ping to the IP address of PCB. So use the PCB IP address. One, 6. So for the question C, they want me to communicate PCA and PCB. So I have already used the command prompt in PCB to ping PCA by using the PCA IP address. So I already get the reply, and that's it. I'm done with the test and troubleshooting the network. So this is how you establish a network in Cisco Packet Tracer. If you have any question, leave it down below, and thank you for watching and stay safe.